So as we already started to talk, catabolism is degradation of substrates, yes? So breaking down, so losing connections between molecules. And it typically, of course not always, releases the energy for the cell to use. It sometimes the main goal of the catabolism is to get the energy. Sometimes the main goal of the catabolism is to get the constituent molecules that are in the molecule that we are breaking down. Yes, so we have some protein, let's say, we are breaking it down, and we get back some amino acids, for example. We can get the energy in the process, but it is not always true. Okay, and the main catabolic course is digestion. So in the digestion, we are breaking down the substances that we taken in the food. Obviously, when we eat something, we get very complex substances, complex proteins into our mouth, and then in the end, the absorption is about getting these extremely small, extremely complex molecules broken down and in the process of digestion in order to be able to absorb very basic substrates for further anabolic processes or catabolic, depends on the situation, like amino acids, like glucose, like lipids, things like that. So one more time, we get some very complex substances, we break it down, and this is catabolism. And then we can use these constituents for our metabolic process. Okay, so yes. So anabolism, we already pointed out, is just a creation of more complex things. Yes, so for example, we have the carbohydrates, and we can connect them to create complex carbohydrates like glycogen. We have the amino acids, and we can connect them in order to create the proteins. Yes, things like that. And there is that this idea is prevailing in a lot of the anabolic processes. Okay. So the net result of the anabolism and catabolism reaction is metabolism. Yes, so the metabolism is both of those things connected. As we already said, it is always the case that we have some anabolic and catabolic process in the body happening. In some cases, some of those processes may prevail. For example, in case of starvation, generally the catabolism prevail. In case of the abundance of the nutrients in the organism, the anabolism generally would prevail. Okay. Also, without the catabolism, the anabolism is impossible in our body, because the catabolism is giving us the energy. Yes, giving us the energy, giving us the basic building blocks in order to have anabolism happening. So anabolism is production. Anabolism is build up. For example, build up of the muscles, but it is true also for any other tissue in the body. Okay, so how is it controlled? How is it controlled whether we would have the anabolism or catabolism apart from this situation, how much of the nutrients we have? On the very basic cellular levels, it is controlled by the enzymes. Yes, so enzymes are controlling the whole metabolism. Yes, so the enzymes, one more time, are the substances that are able to control, usually speed up, the chemical process in the body. This can be any chemical process. However, in order for our organism to have a full control over those chemical processes, to have full control over its enzymes, we need also a lot of specialized substances, let's say. What are those specialized substances can be? It can be, for example, some vitamins, yes? It are also some microelements. So So without them, our organs would lose the ability to fully control the chemical processes that are in the body, because would be unable to produce some enzymes, for example. Okay. What is also important that enzymes are not working in all situations. Yes, so for example, some enzymes would work in a more acidic pH, some more in more caustic pH. Some enzymes would be more active in higher temperature, some in the lower temperature. Some need some activators. Yes, they're regulated by something. And so on and so on and so on. Yes, so there's a lot of conditions that need to be met in order for the enzymes to work efficiently and as we want. It also includes these vitamins, these microelements also, of course. But it also is just about the compartment of the cell that we are in. For example, we learned that when we have the Golgi apparatus, for example, or endoplasmic reticulum, we have the cell membrane, the lipid bilayer, that is creating some compartments. In this compartment, we can create a very specific, very specialized environment for some enzymes to be most active. In other compartment, those conditions can be completely different, and other enzymes will be very efficient in acting its magic. Also, enzyme is not creating the chemical reaction itself. We need substrates that will be used in order to create some substance in this process of anabolism, or to break it down in the process of catabolism. Yes, for example, there would be no breaking down of glucose in the process of cellular respiration if you would not have any glucose there. Also, from the perspective of the kinetics of the enzyme, so how exactly it works, it also can act with different speed. Yes, so some processes like ATP production through the glycolysis can last long, can last short. And we can partially measure the speed of the enzymes by checking how fast the substrates are changing into the products. Yeah, that's a very simple chemical measurement. And what else is important? You need to remember that most enzymes are proteins. Yes, so when you think about proteins, you probably think about some sarcomers, you probably think about bones, the collagen in the bones, collagen in the skin, things like that. But it's also really a lot of classes of the proteins are the enzymes, yes, because those are just so central to our metabolic process, to controlling the metabolic process. Okay, and there are a lot of isoenzymes, yes, so isoenzymes are just the types of enzymes, because if we need so much fine-tuned control, we also need so much of fine-tuned enzymes that can be regulated in different way, that will have different speed, that they can work in different conditions, for example. And also we have some variability between people, so we can have different enzymes between ourselves in a group. Not all of the enzymes are completely the same in different people. Okay, about this we already talked about. Okay, so as we already pointed out, the cellular respiration is the example of the catabolic process, and I suppose it's quite obvious, but let's tell it one more time. We have, for example, the glucose, and we break it down into the carbon dioxide and water. Yes, so we are breaking down more complex structure like the glucose, and we are getting some energy from it, and we get back the far simpler molecules like the carbon dioxide and water. Of course, the glycolysis is also the catabolic pathway, but this, as we already mentioned up a lot of times, the way without the oxygen. Okay, thank you.